Okay, so sometimes we can actually recognize that it's redox because these common oxidizing and reducing agents show up in there. Just like we got used to recognizing double replacement and knowing it's not redox, we can recognize these things and say when these are in there, there's a good chance it's redox. Not always, but there's a good chance. So the dichromate ion, the permanganate ion, nitric acid, big oxidizer, we're going to use that in lab this week. The halogens and oxygen are oxidizing agents. It doesn't mean it's always redox, but it often is. And the reducing agents are hydrogen, metals, and carbon. Now, as we go through this redox, we have to learn how to balance these redox equations. These things are often written for us in the ionic form in terms of a net ionic equation. And if you glance at a net ionic equation, it may seem impossible to balance it because you'll look at it and you may be missing elements on one side or the other because we've canceled out all of the spectator ions. So we have to balance either in acidic or basic solution. If we're in acid solution, there's lots of hydrogen ions floating around. If we're in basic solution, there's lots of hydroxides floating around. So we have a well-defined stepwise process that has to be used in order of the steps in order to balance these equations. And as we go through them the first time, it's going to seem crazy, like, well, I'll never remember that. But as we go through an example, it'll start to make more sense, I promise. So you write the skeleton equation, usually ionic, divide into two half reactions, balance everything except hydrogen and oxygen by inspection, as we've done before, add water to the side that needs oxygen, add hydrogen ions to the side that needs hydrogen, add electrons to the more positive side to balance the charge, then look at the two halves, make the number of electrons in each half the same, add them back together, and cancel out anything that appears on both sides. So it makes no sense without an example to explain it. So when we look at this, we have the permanganate ion plus sulfurous acid making sulfate plus manganese. Now, at first glance, you might think, oh, okay, one manganese. But when you get to hydrogen, two hydrogens, there's no hydrogen over here. So without the process, you have no idea how to deal with this. So we have to go through the steps because you cannot balance it on inspection. So the first step is to separate these things into two half reactions. And we do that by looking at the species that belong together. This ion has manganese in it. This has manganese. So we can say that we need the two manganese species in one of the half reactions. So we write permanganate yields Mn2+. We put both manganese-containing species in one equation, keeping them on the appropriate side of the equation. Now we go to the sulfur half. I have H2SO3 yields sulfate. So I've separated into a manganese half and a sulfur half. Now what we want to do is balance the two halves going through the rest of the steps. I find it easiest to just do one equation, one half all the way through, then do the other half. So we'll start with the manganese half. It doesn't matter which one you start with. And as I'm demonstrating this, I'm going to rewrite at each step for the first couple of problems. After that, I won't because it takes too much time rewriting everything. So we balance anything that is not oxygen or hydrogen on inspection. One manganese, one manganese. Now we balance oxygen. 4 oxygens, no oxygens. So I add 4 waters to the side that needs oxygen. So permanganate yields Mn2+ plus 4 waters. 8 hydrogens, no hydrogens. So 8 hydrogen ions plus permanganate yields Mn2+ plus 4 waters. Now I should be balanced for mass at this time. Now I need to balance the charge. So I evaluate the charge on each side of the equation, and then I add electrons to the more positive side. I have a plus 8 and a minus 1, so that gives me a positive 7 over here, and I have a positive 2 on the right-hand side. So when I look at this, in order to make them the same, the only thing I have to work with is electrons, so I add 5 electrons to the left-hand side, so I now have 8 hydrogen ions, a permanganate ion, a manganese ion, plus 4 waters. So now if I didn't make a mistake, I should have a balanced half reaction. So I check again. When you get to the half reaction, stop and check. 8 hydrogen, 4 times 2, 8 hydrogen. 1 manganese, 1 manganese. 4 oxygens, 4 oxygens. Negative 5 minus 1 is a negative 6, plus 7 gives me negative 6 plus 8, not plus 7. That was from before. Negative 6 plus 8 gives me a positive 2. Over here I have a positive 2, so I have a balanced half reaction. So now we're going to do the same process on the other half.